Hello students. Next we look into the transmission parameter. In transmission parameter, the equation that we are interested in is the relationship between input and output. That means we are interested to find out what is V1 with respect to V2 and I2. And we are interested in finding I1, how it is related to V2 and I2. And unlike what we had done in the case of the previous admittance parameter or impedance parameter, here it is going to be negative relation and it is AV2, BI2, and for the second equation it is CV2 and DI2. So this is the equation that we are interested in, from which this relation we will get the value of ABCD. So you should remember that only in transmission parameter we are having here negative. Previously in all the other parameters we had taken it as positive. Now this equation can be written as in matrix form as V1 I1 is equal to matrix A, B, C, D. Now you might be asking, so where did that minus go? That minus I am going to take it here, V2 and minus I2. V2 and minus I2. Okay, and this is basically what is called as the transmission parameter. This is called as the transmission parameter, or also called as T parameter, or more popularly known as ABCD parameter. This transmission parameter or the ABCD parameter you will learn a lot, or you will use a lot when you study subjects like microwave engineering and all. Anyway, for us what is important is that we have to get the equation in this form. See why it is called as transmission parameter, because it is trying to find out the relationship between input. You can see here this is input and this is what, this is output. So it is trying to find the relationship between input and output. Now you might be thinking why we have taken it as negative, because we are talking about what is going from one end to the other end. So basically we want what is the current going in the output in this direction. That's why we have taken I2 as negative here. And only for the case of transmission parameter we will be interested in this equation as minus. Okay, so now from here I can define what is A, what is B. So as you know, for finding out A and C I have to make I2 equal to 0. So if I2 is equal to 0, how do I make I2 is equal to 0? By keeping this as open circuit. That means if I am going to keep this as open circuit, and here I connect a voltage which is V1, okay, and because of which there is a current I1 flowing, then I am having the condition that if I2 is equal to 0, that is output port is open circuit. Okay, then I will have the equation V1 is equal to A V2 minus 0, or I will get V1 by V2 is equal to A, or I will get A is equal to V1 by V2 when I2 is equal to 0. And this is called as open circuit voltage ratio. Why? Because you are having the ratio between input voltage and output voltage. So this is the voltage ratio. And why is it open circuit? Because the output port we have kept as open circuit. So we will call it as open circuit voltage ratio. Sorry, voltage ratio. Next, the second equation. So in second equation, I will get I1 is equal to CV2 minus 0, or I will get the value of C as I1 by V2. So what is this? This is admittance, correct? This is admittance, but it is admittance between the input and the output. That's why I1 is the first port and V2 is the second port. So this is a transfer admittance obtained when you make it open circuit. So this is I2 is equal to 0. So I call this as open circuit transfer admittance. Okay. So we have got the two values A and C. Sorry. Next, if I make V in this equation, in this first equation, if I make V2 is equal to 0. Now, how do I make V2 is equal to 0? For making V2 is equal to 0, I have to short circuit this. So I will write this is short circuit. Then this becomes V2 is equal to 0. In the previous case, I2 was becoming 0 when it is open circuited. Here, V2 is going to be 0 if it is short circuited. And here we are having the voltage. Suppose V1 is the voltage that we are giving here. Then we will write that is port, that is output port is output port is short circuit. Then if output port is short circuit, see, I will get V2 is equal to 0. Then I will get V1 is equal to 0 minus BI2. Have a look here, first equation. So it is V1 minus Y1 is equal to 0 minus BI2. Therefore, I will get B is equal to V1 by minus I2. I will get V1 by minus, or I can write minus V1 by I2. Then V2 is equal to 0. So this will be obviously short circuit. Voltage by current is what? Impedance. So this is short circuit impedance, but since it is between port 1 and 2, I will call it as transfer impedance. And because it is negative, I will call it as negative short circuit transfer impedance. That is B. And what about the second equation? So second equation will be, and I1 is equal to V2 is 0, so 0 minus DI2, or I will get D is equal to minus of I1 by I2, which is basically a current ratio when V2 is equal to 0. So this one I will call it as negative short circuit current ratio. Okay, now when we write ABCD, always remember A is a voltage ratio, so it will have no unit. So it will be no unit. Okay, whereas B is what? It's a transfer impedance, so its unit is ohms. Similarly, C is transfer admittance, so its unit is mho. And the last D is a current ratio, and because it's a ratio, its unit is also no unit. Okay, in impedance, what was the case? In impedance, all was Z11, Z12, Z21, Z22, they were all ohms. Whereas, the admittance one, which was Y11, Y12, Y21 and Y22, this were all the values were in mho. All the values were in mho. That is the inverse of ohms. Whereas when we come to transmission parameter, These two values are the impedance and the admittance, and these two are unitless because it's basically voltage ratio and current ratio. So these you should remember. So these are what are the transmission parameters or ABCD parameter or T parameter of any two-port network. Now let us look at the symmetry and reciprocity. Now for the condition of reciprocity, we will read the same statement that we have done for impedance and for admittance. The two-port network is reciprocal if the ratio of the excitation at one port to the response at the other port is the same if the excitation and response are interchanged. If you remember, in impedance parameter, we had taken this as minus, both sides we had taken as minus minus. But as you know, both sides taking minus, it's one and the same. That means it does not matter if you are making it positive, because for definition purpose we had taken it as minus, but it's as good as mathematically it's as good as writing both sides positive, so we will take positive. Similarly, you will remember that in admittance we had taken it as I2 by V1 here, and here I1 by V2. Why? Because there it was admittance, that's the reason why, but the ratio is always between the voltage at one port and the current at the other port. That is what is this equation. So now for the condition of reciprocity, this is what we have to see. Okay, now just remembering this equation and the ABCD parameter equation, you can do the derivation. How? So how to find out what is the condition? So we know that the ABCD parameter, look here, I am always writing it as ABCD parameter because that is most commonly used. Okay, so ABCD parameter is basically given by, it basically gives the relationship between the input and the input and the output. So V2 minus I2, V2 minus I2, and it is related by A, B, C, D. This I will name it as equation number 1. This I will name it as equation number 2A. This I will name it as equation number 2B. Okay, so first I have to find out the left hand side, which is V1 by I2. So if V2 is equal to 0, why I am taking V2 is equal to 0? Because I want to find this side, the left hand side. So if V2 is equal to 0, the equation will become what? If I am going to make V2 is equal to 0, the equation becomes V1 is equal to minus BI2, correct, and I1 is equal to minus DI2. Two equations, 2A and 2B, I have got reduced it to this form, correct. Why? Because I took V2 is equal to 0. Now I want only V1 and I2. I want only V1 and I2, for which only this thing is enough. I don't need this equation. So therefore V1 by I2, when I am going to take V2 is equal to 0, is basically minus B. From which equation? From this equation. Okay, I have not used the second equation. Okay, so this equation is the first one. So I will write this is equal to equation number 3. Okay, now what is the second? Right hand side, I have to make V1 is equal to 0. So I am going to write, if V1 is equal to 0, then what happens to equation 2A and 2B? It is 0 is equal to AV2 minus BI2, and I1 is equal to CV2 minus DI2. Okay, let me name this as 4A and this as 4B. Okay, now see here, we have made, for the right hand side we have made v1 is equal to 0. Okay, now I want only v2 and i2. Why? Because that is what is the two values. So sorry, v2 and i1. So I want to avoid the i2 here. So to avoid i2, I want to write i2 only in terms of v2 and i1. So therefore from 4b, that is this equation, I will get what is the value of i2. I will get i2 is equal to, okay, what is i2? cv2, just wait, it is v2 by i1, sorry. So I want i1, everything in terms of i1. So I want to avoid i2, correct. So this is, just hold on. So I2 is going to be I1 minus CV2 divided by D. I2 is equal to, from where? From 4b. And I have forgotten this minus, so I will write this minus here. If I take that minus on top, I will get CV2 minus I1 divided by the whole divided by D. CV2 by I1 the whole divided by D. Correct? See, again, what I am trying to find out, I am trying to find out V2 with respect to I1. I don't want I2 current. Just hold on. With respect to I1, I want to actually, take out I2. Correct. Now substituting this in 4a. So if I substitute this in 4a, what will I get? I will get 0 is equal to AV2 minus BI2. Now what is I2? It is CV2 minus I1 by D. Not small d, capital D, sorry. Or let me write D as CV2 by D. I'll write CV2 by D and I1 by D. Okay. So now from this I will get 0. I will bring, okay, let me first do this. I will take A minus BC by D and V2 as common, plus, because minus and minus will become plus, B by D into I1. Correct? From which, see what I wanted V2 by I1. So now I have got V2 and I1 here. So this one can be written as, therefore, if I bring the other side, then it is going to be minus B by D I1 is equal to AD minus BC divided by D into V2. Therefore, V2 by I1, exactly V2 by I1 when V1 is equal to 0. So V2 by I1 when V1 is equal to 0 is, so if I look what it is going to be, V2 by I1 is going to be D and D will cancel off, and I will get minus B divided by AD minus BC. This is going to be my equation number 5. Okay, so these two I have found out. Okay, these two I have found out. Let me put them in box. So this is the first one that I found out, and this is the right hand side, which is the one I found out second. Okay, and what does the condition for reciprocity says? That both should be equal according to equation 1. So here I will write, for reciprocity from equation 1, the condition is equation number, the ones I have put in box, that is equation number 3 and 5. Equation number 3 should be equal to equation number 5. Hence, let me write the final statement. Hence, for ABCD parameter, the condition for reciprocity is see, equation number 3 and equation number 5, if you have to equate them, that means if both of them have to be equated, you can see here there is nothing in the denominator, or you can say that there is a 1 in the denominator. Here there is AD minus BC in the denominator, so AD minus BC should be equal to 1. So I will write AD minus BC should be equal to 1. So if the circuit has to be reciprocal, then AD minus BC has to be 1. See, have a look. This is A, this is B, this is C, this is D. Okay. This, if I am trying to find A into D minus B into C, it is basically what? It is basically the determinant of the ABCD parameter. It is the determinant of it, and that determinant should be equal to 1. The determinant of the ABCD parameter should be equal to 1. Okay, then the circuit is a reciprocal circuit, or the condition for reciprocity is AD minus BC is equal to 1. Next, we have to look for the condition of symmetry. The condition of symmetry says for a network to be symmetrical, the voltage to current ratio at one port should be same as the voltage to current ratio at the other port, with one of the ports open circuited. So the equation that we write for condition of symmetry, that we have already always written for the other cases also, that means admittance and impedance we have written. It is V1 by I1, that is the ratio, the voltage to current ratio at the input should be same as the voltage to current ratio at the output when the other port is open circuited. Open circuited means I2, this is the other port when we consider first port, and for the second port, the first port is going to be open circuited. So this is the equation that we have to find out. So this one I will write it as equation number 1. Every time we are using the same procedure. Okay, we have to find out the left hand side, we have to find out the right hand side. So the first thing is we will try to find out when first is ABCD parameter is given by the relationship of V1 and I1 with respect to V2 and I2 with respect to V2 and I2 is AV2 BI minus BI2 and CV2 minus BI2 minus BI2. Correct? So this is equation number 2A and this is my equation number 2B. Now, if I2 is equal to 0, why I am writing I2 is equal to 0? Because in the left hand side I have to make I2 is equal to 0 and find V1 by I1. So if I make I2 is equal to 0, then 2A becomes, so the equation 2A, what will happen? It is V1 is equal to AV2 minus 0. Therefore, V1 by V2, I have to not take the ratio, I have to take the ratio of V1 and I1. So let this be, okay. So it is V1 is equal to AV2, and similarly for the second equation, and 2b becomes what? I1 is equal to CB2, correct? Therefore, if you take these two equations, from this one you will have V1 and I1, isn't it? So V1 by I1 when I2 is equal to 0 is basically dividing AV2 by CV2, where V2 cancels off, correct? So I will not write V2, I will not write V2. So this is going to be my equation of the left hand side. Let me put this in the box. Okay, so I have easily found out. Now for the second case where I1 is 0, so I have to find out if I1 is equal to 0, if I1 is equal to 0, then only need to look at equation number 2b. Then equation number 2b becomes what? 0 is equal to CV2 minus DI2, correct? Yes, or DI2 is equal to CV2, from which what is my interest? My interest is to basically find V2 by I2, which is actually directly this one. Therefore V2 by I2 when I1 is equal to 0 is V2 by I2 when I1 is equal to 0 is D by C, correct? It is D by C. This also I will put in bracket and I will name those equations as 3 and 4. This is equation number 3 and this is equation number 4. Okay, so equation number 3 and 4. Then we'll write for symmetricity, for symmetric circuit, equation number 3 should be equal to equation number 4. Equation number 3 should be equal to equation number 4. Now see, here in the numerator we have A, and for equation B, for the numerator is D. The denominator is same. So if 3 and 4 should be equal, that is A should be equal to D. Therefore, now I will write using a different color. Hence, for a circuit to be symmetrical, its ABCD parameter should follow the condition. What is the condition? A should be equal to D. A should be equal to D. Okay, that means if I am having a matrix ABCD parameter, if I am having A, B, C, D, then for the circuit to be symmetrical, A should be equal to D. A should be equal to D. This we should not forget, and this I will again write it in the main result that we had written here. So H parameter I will T parameter, or let me write here as ABCD parameter also, so that we don't confuse it too much. I will write it here as ABCD parameter or transmission parameter. And what is the equation? The equation we have seen is basically relating V1 and I1 with its output port, which is V2 and I2, but there is a negative I2. So V2 minus I2, and the relationship is A, B, C, D. And just now we saw what is the condition for reciprocity. For reciprocity, we have found out that the determinant value should be 1. That means A into D minus B into C should be equal to 1. That is the condition for reciprocity. Similarly, the condition for symmetry, we found out that A should be equal to D. Okay, so this sheet we have filled. Now H parameter is remaining. Anyway, now we will try to do a problem based on this. Determine the transmission parameter of the network shown. Now, I have already told you, for the case of impedance parameter, we use only KVL. For the case of admittance parameter, we use the technique of only KCL for solving the problem. So, impedance parameter KVL, admittance parameter KCL. What about transmission parameter? See, you can use either KVL or KCL. With the help of both, you can find out the answer. Okay, so I know that for most of the student, KCL is most easiest method, so I will follow KCL here. Okay, so first thing that we have to do is we have to mark the currents and the voltage. So here it is I1, so I will mark this as I1. This is I2, which I will mark like this. This is I2, sorry, this is I2, and this current I will again take it as I3. Now 1 Henry I can write it as S, 1 ohm I will leave it as 1 ohm itself, and 1 farad I can write by 1 by 1s, which is 1 by S. So this becomes 1 Henry becomes S, this is 1, and this becomes 1 by S. Okay, now now for solving, KVL at mesh 1, which is mesh 1, this one, first one. So I will get this as plus and this as minus. So front of the element I will get V1 minus S I1 minus I2 is equal to 0. Okay, from which I can very well get V1 is equal to SI1 minus SI2. So this is my first equation. Okay, now KVL, so this is I3, sorry, so this has to be I3. Okay, I3 and I3. Okay, now KVL at mesh 3, which is mesh 3, the center one. Okay, the center one is going to be, this is going to be plus minus plus minus plus minus. If I am going to take back of the element, then I will get S I1 minus I3 minus I1 plus I3 into 1 plus 1 by S I3 plus I2. Why plus I2? Because it's the same direction as I3, and that is equal to 0, from which I can try to separate out I3. So let me write S for this I3 plus 1 for the second case. For the third case it is plus 1 by S I3 is equal to I1 term I will take the other side, which becomes S I1, and I2 term also I will take the other side, which becomes 1 by S minus of 1 by S I2. This gets solved to S square plus S plus 1 divided by S into I3 is equal to SI1 minus 1 by S I2, from which if I am going to find out what is I3 will be S square divided by S square plus S plus 1 I1, okay, minus S and S will cancel out, and I will get 1 divided by S square plus S plus 1 I2. Okay, so I have got what is I3 with respect to I1 I2, so this I will write it as equation 2. Then I will write KVL at mesh 2. See, I could have written KVL at mesh 2 in the start itself, there is no problem. But anyway, I have written it in the order 1, 3 and 2. I can write it in the order of 1, 2 and 3. Anyway, so now for the second one, it is V2. So this is plus, this is minus. So I will get V2 minus 1 by S I2 minus, not minus, plus I3 is equal to 0. So now from here, if I write what is V2 is equal to 1 by S I2 plus 1 by S I3, correct? This I will write it as my equation number 3. This I will write it as my equation number 3. Now I3 I already have in equation number 2. I can substitute that in equation number 1 and get rid of my this I3 as well as this I3. Okay, and I will get all the equation in terms of V1 I1 and V2 I2. So therefore I will write substitute equation number 2 in 3. If I substitute equation number, let me start with equation number 1, not 3. So substituting equation number 2 in 1, I will get, what is equation number 1? Equation number 1 is V1 is equal to SI1 minus of S, now within brackets I will write whatever I have got for I3, which is S square divided by S square plus S plus 1 I1 minus 1 divided by S square plus S plus 1 I2, correct? From which I can join the I1 parts together. I will get V1 is equal to S minus S cube divided by S square plus S plus 1 into I1 and minus and minus becomes plus S into 1 divided by S square plus S plus 1 into I2. Here for finding out I can do the cross multiplication, which comes out to be S cube plus S square plus S minus S cube, okay, minus S cube divided by S square plus S plus 1 I1, where these S3 minus S3 sorry S cube and this S cube can cancel off, so I will cancel them off. Okay, and this one I can maybe write it as S into S plus 1, but let me avoid that right now. I will just write S into S plus 1, or I can take S commonly outside and I will write this as S into S plus 1. Okay, S into S plus 1. Why? Because S into S plus 1 is S square plus S. That I have taken out and written it in the factors like this. If I don't write the factors, it's not a big issue, but somewhere you will have to cancel off everything. So in a way it is good to always keep the equation small. So S square plus S plus 1 into I2. This is my V1, and this I will keep it as equation number 4. Similarly, if I am going to substitute equation number 2 in equation number 3. What is equation number 3? Equation number 3 is this one. So V2 is equal to 1 by S I2, let it remain there, plus 1 by S. Now instead of I3 I will write s square divided by s square plus s plus 1 into I1. Where I am taking that from? I am taking from this equation number 2. Minus 1 divided by s square plus s plus 1 I2, which I can again expand for I1 and I2. So I will write B1 is equal to 1s, from the numerator will get cancelled off. So I will get s divided by s square plus s plus 1 I1. Okay, and sorry, 1 by s, yeah, correct. Then plus I2 terms are 1 by s minus 1 divided by s into s square plus s plus 1 the whole into I2. Now here you see there are two components. One is s multiplied with here s square plus s plus 1. Whereas here there is only s. So only here I have to multiply and divide with s square plus s plus 1 for making the denominator common. We use that technique for fractions, isn't it? So I will write, sorry, this was V2. So this is also V2. Okay. So V2 is equal to s divided by s square plus s plus 1 into I1 plus, so now I have to write here s square plus s plus 1 minus 1 divided by s into s square plus s plus 1 into I2. Now see here, this minus and minus will get cancelled off. What I will have is s square into, sorry, s square plus s, and I know that s square plus s can be written as s into s plus 1, isn't it? So I will write that directly here. You can write it as a next step, no problem, but I will write it as a single step. I will write this as s into s plus 1. But see here, s and s will cancel off. So I will basically get it as s plus 1 and divided by s into s plus 1. Correct? This I will write it as equation number 5. But before that, let me do one more step, because see, now this could have been equation number 5. Now you might be thinking, let me write first as equation number 5. Don't write in your notebooks, because I will be rubbing this in a short while. See, now you might be thinking, can we do it? See, V1 is I1 I2 and V2 is I1 I2 with respect to I1 I2. We have got this equation, but what is originally the Z parameter equation? The T parameter equation. The T parameter equation is A V2 I2. So in the right hand side it should be V2 I2. Okay, and in the next equation I1 V2 and I2. Now this, look at the second equation. The second equation has I1 V2 and I2, that is there in our this equation. So I will write, therefore, I will do this further. Therefore I1, so if I want to find I1, what will I do? I will take this one the other side, or this one I can take it here, and V2 I can take it the other side. Correct? So if I do that, I will get, let me write it in little bit elaborate way so that some of the students are able to understand. So I will take this one the other side, so it becomes minus s divided by s square plus s plus 1 is equal to minus V2 plus s plus 1 divided by s square plus s plus 1 into I2. This is I1, sorry. So now look, this is the second, this looks like the second equation. The only thing is that I1 does not have any coefficient, so I will take this coefficient. This coefficient I will take it and I will put it in the other side. So what will happen? This one will go into the numerator side and this will come in the denominator side. Okay, and this negative also I will take, so that negative, when I take it here, it will become positive, whereas here it will become negative, isn't it? So let me write that in an elaborate way, and then we will see. So if I write this one this V2 will be remaining there, so that I will write it as V2 itself. Okay, V2 itself. Now this one comes from the denominator, it comes here as S square plus S plus 1. That minus is still here, I forgot to write it. Yeah, and this minus S will come in the denominator, so this will come as minus S, and from here this will go. Okay, and similarly here also I will have to multiply the same factor. So I will get it as multiplied with whatever I have written here. What was that? S square plus S plus 1 divided by minus S into I2. Correct? Now what is going to happen is this minus and minus will cancel off. Correct? And here this denominator and this denominator basically cancels off. Sorry, the denominator and numerator basically gets cancelled off. So this minus S can come actually, it can come here. And that minus, I will take it and put it here. So this plus is not there. This plus has become minus. And this I2, I will bring it close. I will write this as, this one I will write it as I2. And this is my equation number, original equation number 5, and this one I am not going to write. Now you can write it as 5 and 6, it does not matter. But I just wanted to show you that it was just one step away, so I have written. So this equation is same as the second equation. So I have got I1 with respect to V2, I2. Now if I take this equation 5 and I substitute this value of I1 here, I will get everything in terms of V2, I2 only. Okay, that means if I substitute equation number 5 in equation number 4. So I will write substitute equation number 5 in equation number 4. Equation number 5 in equation number 4. Then what will you have? Equation number 5 in equation number 4. I will get, let me write that. It is V1 is equal to S into S plus 1 divided by S square plus S plus 1 into I1. Now what is it that I have found out of I1? I have found out of I1 that it is S square plus S plus 1, S square plus S plus 1 divided by S into, okay, into V2, correct, into V2 and minus of S plus 1 divided by S I2. Okay, that was I1. And what about the second part in that equation? The second part is this one, isn't it? So S divided by S square plus S plus 1 I2. So now this, if I am going to expand it, I will get, see here, this S and this S will cancel off, this denominator and this numerator will cancel off, so I will get only S plus 1 V2. Now again, if I am going to take this one this side, then this S and this S will get cancelled off, correct? So I will get minus of, minus of, within bracket I will put S and S cancel, so S plus 1 the whole square divided by S square plus 1, S square plus S plus 1 I2 I will take out commonly, and then I will write the second part, which is S into S square plus S plus 1, that into I2, that into I2. Clear? Okay, have I missed out something? Let me have a look. So S plus 1 is there. S and S basically cancels off. Okay. The only mistake is that here that minus was there, so I should have written this as minus and the other one is plus itself. So this is minus. Okay. Now if I do this, I will get minus of s square. Uh, yeah, minus of s square plus 2s plus 1 plus s divided by, the denominator is common, s square plus s plus 1, which is multiplied with I2, and this part is V1 is equal to s plus 1 V2. Now if I take this minus inside the bracket, then I will get all of these will become minus. So this is minus, this will also become minus, this will also become minus, the bracket will open. So I will get something like minus 2s, minus 1 and plus s. See what will happen? This minus 2s and s will basically become, so s square minus of s square minus of s minus of 1, from which I can take minus commonly outside and I will get s square plus s plus 1. That is going to happen in the numerator. So I will get v1 is equal to s plus 1 v2 plus minus of s square plus s plus 1 divided by s square plus s plus 1 I2, where this 2 actually get cancels and what remains is only this minus. Therefore, I will get v1 is equal to s plus 1 v2 plus, not plus, minus I2. Minus I2. That I will put it again in the box because this is my second equation. This is my second equation, and let me write, this is my second equation, which was, what was the previous equation I wrote? It was 5, so this one I will write it as 6. Okay, just because it's in the other page, I will write equation number 5 here again. Equation number 5 was I1 is equal to, remember, I1 is equal to s square plus s plus 1 divided by s into v2 minus, remember it was minus s plus 1 by s I2. So this was equation 5. Because it was in the other page, I wrote it here. Okay, so this was equation number 5. Comparing this, comparing with, what is the ABCD parametric equation? B1 is equal to A V2 minus B I2, and I1 is equal to C V2 minus D I2. Now look at equation number 6 and 5. These both equations are basically like this itself. So I can write finally that A, B, C, D can be written as, now here you have to be always careful because people make a mistake of this minus sign here. Always be careful. So what is A? A is going to be s plus 1. Okay, A is going to be s plus 1. Similarly, C I can write, similarly B I can write, similarly D also I can write. Each of these equations I can write what the value is. So I will write this as s plus 1. The second one, B will be equal to 1. C will be s square plus s plus 1 by s, and this one will be s plus 1 by s. See, I have not taken the minus sign because here also minus, here also minus. If it is not minus, if something is plus, you have to make that change. Many people make that silly mistake when they do transmission parameter. So this is the final answer. Okay, so this is the final answer, and that's how we solve. Now you might be thinking that, oh sir, ABCD parameter is slightly having little bit length. See, there is a very simple method of doing this, but that simple method I will take it only in the next section after I complete this portion, and then I move on to interconnection. There uh, we will have a formula for finding out t parameter very easily. Okay, that I will tell you once we reach there, but as of now this is what is the step we have to carry out. Thank you.